In the original implementation of Ethernet, all the machines that are on the same LAN had the same physical wire connected to them. So they were all seeing the same 1 and 0 signal, all seeing the same synchronization bytes and starting byte. And then the frame that's after that with its MAC address would tell the card whether to pay attention to that frame or not. It turns out that modern Ethernet is always switched. Every Ethernet device has a separate physical wire from that Ethernet card over to the switch, and that makes the switch's job more important, but also makes traffic flow better. It turns out that this also means that the MAC address is less relevant. Ethernet cards are not getting frames that they need to ignore because of the differing MAC, because they just won't be sent those frames. So these switches could actually synthesize a suitable MAC for larger levels of network communication, but the MAC is still there for many purposes. Also, even though a MAC is not so important on a switched Ethernet layer, many things that are encoded as Ethernet frame are not physically Ethernet at all. If by Ethernet we mean a wire with the RJ45 plug on the end that plugs into a card in the back of your machine, Wi-Fi also claims to be Ethernet, even though it's encoded in the air in a slightly different way. And it turns out the easiest way to make a new kind of physical device is just to pretend to be Ethernet for the link layer and up. The switched nature of modern Ethernet makes certain things easier, because a laptop has a wire going just to its switch, and only the laptop and the switch have to coordinate to decide who is actually sending a signal over the wire at a given time. Traditional Ethernet and other media like Wi-Fi have a harder problem to deal with. There are multiple entities that are all sharing a single communication medium. They need to take turns, they need to coordinate with each other and decide who gets to talk now so that they don't talk over each other or interfere with each other's communication. So we're going to have just one of these entities talking at a time over the medium, and we're going to look at ways to do that fairly and efficiently. Fairly meaning that one laptop doesn't dominate the conversation here and take over all the media so that these other two laptops don't get to talk. Even though one is talking at the same time, we will need some protocol to let them switch off and give everyone an equal amount of opportunity to talk. But at the same time, we don't to not waste bandwidth. We don't want to allocate time to this laptop if it has nothing to say. So we'll look at different protocols for achieving those goals.